Alright, so this is Unit 6, Lesson 7. Unit 6 is Conics. Lesson 7 is starting to talk about parabolas. So we talked about parabolas in Pre-Calc 11. We're going to expand on what we know about parabolas in this lesson right here and the next 3 lessons. In this lesson, we're going to look at the equation of a parabola in conic form and then how to interpret that equation for some key features. So given our conic equation, if a is 0 or if b is 0, we have a parabola. If a is 0, that means there's no x squared term, or if b is 0, that means there's no y squared term. In either situation, it's a parabola, but they both can't be 0, only one. You can only pick one. So if b is 0, we have an equation with an x squared, and so it can be written in this format, where we have x minus h squared, and we have this 4p times y minus k. And notice y minus k is not squared. And we have this constant 4 and this multiplier of p. And so if we break this down, we know from Pre-Calc 11 that a parabola is kind of this U shape. It opens up or down, and it has a vertex, and it has an axis of symmetry that goes through that vertex. The axis of symmetry is that vertical line that cuts the parabola in half. It makes the one side a reflective mirror image of the other side. And so HK is our vertex. The axis of symmetry is the equation of the line x equals h. And again, h value is just the x value of the vertex. Our P tells us if it opens up or down. P tells us many things, but at this point, P tells us if it opens up or down. If P is a positive number, this parabola is going to open up, just like this example. If P is a negative number, then the parabola would open down. Alright, so here's one piece that's new for Pre-Calc 12. Parabolas can be sideways. So if you have a y squared, like we have y minus k squared here, if we FOIL that out, there'll be a y squared term in there. And then over here, we just have an x term without a squared. And so if that's the case, what we're going to get is a parabola that's on its side. It opens to the right or to the left. Again, the p-value, or the hk, tells you the vertex. The p-value, well, let's go in order there. Axis of symmetry. If the parabola opens up to the right or left, that means the axis of symmetry that cuts it in half as a symmetrical mirror of itself, then that axis of symmetry is going to be a horizontal line. It's going to cut through the vertex. It's going to cut the parabola in half. It's going to be the equation of the line y equals k. So before, when you have an x squared, it's x equals the h value. Now we have y equals the k value, which just makes sense because y is equal to the y value of a vertex, and the y value of a vertex is k. Okay, so now let's talk about the p. If p is some positive number, it's going to open to the right. And if p is some negative number, then our parabola is going to flip and it's going to open to the left, which should be intuitive because to the right is positive and for x's, and for y's going up is positive. And so left and down are both negative directions for x and y axes accordingly. So it just makes sense that those will both be opening. Those would be negative p-values. So anyways, that's that. Vertex, axis of symmetry, and then using the p-value to determine which direction it opens up in. So if I give you an equation, for example, here's 2 equations. We can find the vertex, the axis of symmetry, and we can find which direction it opens, just by looking. So we have a x plus 1, which means the h value is negative 1. We have y plus 5, which means the k value is negative 5. So our vertex is negative 1, negative 5. We have an x squared term, which means it's going to open up or down. We have a 16 right here. And so don't forget the formula has 4 times p. So to get p, I need to take this 16 and divide it by 4 basically. So 16 divided by 4 is 4, so p equals 4. Or I can say 4 times what equals 16? Well, 4 times 4 equals 16. So by that logic, p is also equal to 4. So our p is a positive number, so that tells us that the parabola is going to open up. So we have x squared, and the fact that there's a positive p-value tells us that we have a parabola that opens up. Instead of left, right, or down, it opens up. Which means we have a vertical axis of symmetry. So x equals the x value of the vertex, or x equals h, or in this case, x equals -1. It's our equation for our axis of symmetry. Second example, our h value is +2, and our y value is -1. So we have a vertex at 2, -1. Since we have a -12 here, divide that by 4, we find that our p-value is -3. Negative p-value means it's going to open down. X squared and negative p opens down. And so we have a vertical axis of symmetry. So x equals 2, because that's the x value of a vertex. So here's two examples when you have x squared. Here are two examples when you have y squared. So y squared means we're going to have a parabola that opens either left or right. Our p-value for the first example is going to be -1, because -1 times 4 is -4. Our p-value for the second example is going to be 2, because 2 times 4 gives us 8. So a negative p-value means this one's going to open to the left. And example B, a positive p-value means it's going to open to the right. Alright, so since we have axis of symmetry, since we have opening left and opening right parabolas, our axis of symmetry is going to be a horizontal line for each of them. For the first one, our y value of our vertex is 7. So our axis of symmetry is going to be y equals 7. For the second one, our y value of our vertex is -4. So the equation for this axis of symmetry, this horizontal line, is going to be y equals -4. Alright, so those are some examples, and we're just kind of digging into the equation of a parabola as it is in conic form. And now we could talk about vertex, we could talk about axis of symmetry from that equation, and we can also figure out what's this new thing, this p-value. And so that p-value tells us if it opens up, down, or if it opens right or left. And I think P stands for Pokemon, so you're going to see Pikachu, which also starts with P, for the next 3 lessons. You're welcome for the Pokemon references. And you know what, Spencer? There are only 152 Pokemon, not 898. Sorry.